In February 2023, the movie Titanic was re-released in theaters worldwide. The film was exactly the same. The novelty? This time it would be in 4K quality. This was done to celebrate the 25th anniversary of the film, and being re-released in a quality in which it had never been seen before caught the public's attention. This wasn't the only time something like this happened. Over time, it became common not only in cinema, but in the entire audiovisual world. One of the remarkable examples in music happened in the past decade when the Beatles albums were remastered and released once again. This became an attraction for many people, as they could finally listen to their favorite album or watch a movie that marked their childhood in a quality never experienced before. Because of this success, it didn't take long for these techniques of improving the quality of photos, videos, or audio to start becoming popular. What was once restricted to Hollywood, which had powerful processes to achieve these qualities, gradually became accessible. And besides being accessible, technology has advanced greatly in recent years. And today, with the introduction of artificial intelligence, we have reached a new level that seemed impossible 10 years ago. If we didn't even expect movies like Star Wars, Titanic, or Lord of the Rings to have this quality, imagine home movies from when you were a baby. It would seem like I'm imagining things or talking about something that belonged to a distant future we see in science fiction movies. But what if I told you that it's now possible to transform any image, including those home videos you have, into up to 8K?
Hey, Pedro here. This video you are watching was originally in Portuguese, my native language. This is the attempt of our team to translate it to English, and I sincerely hope you enjoy it. Your feedback is extremely important to us. Now, back to the video.
But to understand this, first we need to understand a few other things. One of the things we need to understand is how movies and television shows were filmed and how that affected the quality. For the purpose of this video, we can divide it into three types of filming: cinematic film, analog, and digital. Cinematic films were those recorded on physical film reels, which could have widths like 16 millimeters, 35 millimeters, and even 70 millimeters. One curious thing about cinematic films is that they were generally recorded in very high qualities, which were even superior to the most recent techniques. The big problem was that these films had to be compressed into smaller formats, causing the quality to be lost in the process. And besides that, since the copies were physical, damage could occur to the films, such as creases, scratches, dirt, which could even affect an entire section of the recording. And because of this process, the impression was that these films had worse quality. But remember, the original recording itself, the one in the studio, the very first one, still had superior quality. Later, two other types were introduced: analog and digital. Analog had lower quality and used different techniques. The way to measure resolution was through horizontal lines. Digital, on the other hand, is what we are most familiar with. Digital quality is expressed in terms of pixels. And when we talk in terms like 1080p, 4K, or 8K, we are indirectly referring to how many pixels are present in the image. The more pixels, generally, the higher the quality of the video or image we are viewing. And here we encounter a challenge. If we have three recordings of the same movie in these three types with a 1080 resolution, which would be the easiest to convert to 4K, the answer that seems obvious is digital. After all, it is more recent and seems to have better quality. And this is true as long as we don't have access to the original recording of the cinematic films. Because if we do, they are much easier to convert to higher qualities. Precisely because they were already recorded with a superior quality that had to be degraded and compressed until it reached the cinema screens in your home. In the end, it was just a matter of taking these original recordings and applying filters to clean up noise and smooth the image. And that's even why, for many people, the first three Star Wars movies from the 70s looked better when released in 4K than the films released in the 2000s. Just a random tidbit for you to share at the bar when someone brings up the topic of movies. But the story doesn't end here. And you might be thinking, what about digital films? Digital films, or even generalizing to digital videos or images, are already recorded in a specific resolution. There is no original recording that a simple treatment can improve, as is the case with cinematic films. If the original digital film was in 1080p, converting it to 4K meant multiplying the number of pixels by 4. In 8K, this increased to 16 times. Just to quantify, while a frame of a 1080p film would have about 2 million pixels, a 4K would have 8 million pixels, and an 8K would reach 33 million pixels. The question we must ask ourselves is, how do we multiply these pixels to reach 8 million or 33 million if you only have 2 million available? Or even less, depending on the resolution with which a video was recorded. Or in other words, how could you watch something in 8K if it was originally recorded in 4K? In theory, the answer is simple. Upscaling with artificial intelligence, that is, increasing the image resolution. But what is upscaling with artificial intelligence, and how has it revolutionized the film, television, and even photography industries? The basis of image with artificial intelligence is precisely to be the solution to the question of being able to multiply the number of pixels to increase resolution. Currently, the term upscaling, or increasing the resolution of an image, is closely related to artificial intelligence. But before they existed, there were already many techniques to achieve this effect without using artificial intelligence. Anyone who works with photography or has used Photoshop is probably already familiar with some of these traditional techniques. The basic idea is to multiply the number of pixels, both horizontally and vertically. This was traditionally done with something called interpolation, which worked as follows. Imagine you have 2 pixels and want to add one more between them to increase to 3 pixels. Interpolation is a technique that analyzes the color of these 2 pixels to predict what the color of the third will be. In the past, the easiest way was basically to repeat the color of one of these pixels around it. But this created a strange effect where it looked like the image had been stretched. Additionally, errors could occur, like in this case of 2 pixels, where the middle one received a color that wouldn't be correct. To avoid this problem and improve image quality, other types of interpolation soon began to be proposed. One example is a technique called nearest neighbors, which analyzes a number of surrounding pixels and then calculates an average to predict what the color of the pixel should be. And although this technique improves as we increase the number of pixels analyzed, it still leaves an effect that very much resembles a square or even something blurred. There are other techniques for interpolation, but in general, their major problem is that they do not achieve the perfection we often seek, and they are also computationally very expensive. But at the same time as these techniques were advancing, artificial intelligence technology was also advancing in parallel. As processors improved, artificial intelligence gained strength, especially in dealing with images and videos. And one of the technologies that gained prominence was convolutional neural networks. They were originally made to process matrices, but their use in images and videos was quickly introduced, mainly to increase image resolution with AI. The process works roughly as follows. Imagine you have thousands of images with originally high quality, such as 4K or 8K. Using a tool that reduces the size of each image by, for example, removing pixels, you can decrease the quality of each one. You can take a 4K image and reduce it to 512 pixels. Then you store all these pairs of images, one with low and the other with high resolution. If you set up a neural network, feed it with low-resolution images, and ask it to develop the same images but in high resolution, it will learn to perform this process to make the images as high resolution as possible, losing the minimum amount of detail. And in the end, we compare the image generated by the neural network with the true high-resolution image and repeat the process until it can return images that are increasingly better and closer to the original. At some point, the difference between the image generated by the neural network and the original high-resolution image will be imperceptible. And then you have a trained model to transform low-resolution images into high-resolution images. And this is the great innovation that I want to make clear and evident. In this case, it was literally a model that learned to do this through training. Whereas in traditional AI image resolution enhancement, there is no learning. It's just an average calculation between pixels to try to predict which color should fit into a gap. With a neural network that has been taught this, and to create a realistic image, it is possible to increase the resolution without the risk of losing quality. Nowadays, even neural networks have evolved into techniques that encompass generative neural networks and even the famous transformers, which, for those who don't know, is the T in GPT. But until then, we are talking about movies and shows that have been previously enhanced and not something live, like a soccer match or the Olympics. How can the image with AI and all this process I just explained involving neural networks be done in real time? The answer is magical. The idea is that these AI TVs have a model trained to use the 512 neural networks, along with the AI image to enhance the resolution of what you are watching. And to do this, the model was trained in the same way I explained a little while ago, using a large amount of videos, movies, photos, and images. So, if you are watching a football match in 4K, the AI TV has been trained on countless images of footballs and knows how they should look in 8K. And then it enhances the quality of the football up to 8K. This process is completely automatic, and if you hadn't watched this video, you wouldn't even know it's happening in real time. Similarly, any content you are watching on the TV will have its resolution upscaled to up to 8K. And if you think this would only work for images that are the frames of the television, you are mistaken. The same technique can be applied to audio. Just as the AI image learns to generate high-resolution images from low-resolution ones, audio can also be optimized. Many people complain that it's becoming increasingly difficult to understand dialogues in current movies and series. And there are so many factors for this that I could make a separate video just on this topic. Feel free to type in the comments if you would like a video about this. But the idea is that by using the same technique, AI TVs can optimize the audio of what you're watching to make it easier for you to understand what's being said. The idea would be simple. Transform audio into spectrograms and train a neural network in a manner similar to training with images. Degrade the quality and use that to learn until reaching the original quality. This would make conversations cleaner and more understandable without the need to re-record everything from scratch. And everything I'm talking about here is not done generatively. Just with a regression neural network, it would be possible to achieve these same effects. In other words, you are not creating something from scratch. You are just teaching a neural network to process existing data without the need to replace it. What I find fantastic is that the entire basis of this technology could be summarized as, to improve the quality of something, we first need to learn to degrade it before learning to enhance it. This is fascinating. We increasingly see interesting applications of artificial intelligence in our daily lives, and it's fantastic to be witnessing all of this. If you showed your past self that it's possible to increase the resolution of a VHS recorded video to up to 8K, they would think it's magic, and they wouldn't be wrong. This type of artificial intelligence application to enhance the way we experience things in our daily lives is often the closest we can get to magic. Thank you very much, and see you next time.